Okay, welcome to my course Cracking the GRE Maths. In this video, we are going to discuss integers. Okay, the integers are the numbers 1, 2, 3 and so on, together with their negatives -1, -2, -3 and 0. Therefore, the set of integers is -3, -2, -1, 0, 1, 2, 3 and infinity. So basically from minus infinity to plus infinity. The positive integers are greater than 0, the negative integers are less than 0, and 0 is neither positive nor negative. When integers are added, subtracted or multiplied, the result is always an integer. Division of integers is addressed below. The many elementary number facts for these operations such as 7 plus 8 is equal to 15, 78 minus 87 is minus 9, 7 minus 18 is 25 should be familiar to you. They are not reviewed over here. The product of two positive integers is a positive integer. The product of two negative integers is a positive integer. The product of a positive integer and a negative integer is a negative integer. When integers are multiplied, each of the multiplied integer is called a factor or a divisor of the resulting product. For example, 2 into 3 into 10 is 60. So 2, 3 and 10 are the factors of 60. The integers 4, 15, 5 and 12 are also the factors of 60. Therefore 4 times 15 is 60 and 5 times 12 is 60. The positive factors of 60 are 1, 2, 3, 4, 5, 6, 10, 12, 15, 20, 30 and 60. The negatives of these integers are also factors of 60. Since for example minus 2 into minus 30 is equal to 60. There are no other factors of 60. 60 is a multiple of each of these factors and 60 is divisible by each of these factors as 60 is divisible by each of these divisors. Okay, 25 is a multiple of only 6 integers 1, 5, 25 and their negatives. For example, the list of positive multiples of 25 has no end: 25, 50, 75, 100, 125, 150. Likewise, every non-zero integer has infinitely many multiples. 1 is a factor of every integer. 1 is not a multiple of any integer except 1 and minus 1. 0 is a multiple of every integer. 0 is not a factor of any integer except 0. Okay. The least common multiple of two non-zero integers c and d is the least positive integer, that is a multiple of both c and d. For example, the least common multiple of 30 and 75 is 150. This is because the positive multiples of 30 are 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330, 390, 420, 450 and so on. And the positive multiples of 75 are 75, 150, 225, 300, 375, 450. Therefore, the common positive multiples of 30 and 75 are 150, 300, 450 and so on. And the least of these is 150. Okay. The greatest common divisor or the greatest common factor of the two non-zero integers c and d is the greatest positive integer, that is the divisor of both c and d. For example, the greatest common divisor of 30 and 75 is 15. This is because the positive divisors of 13 are 1, 2, 3, 5, 6, 10, 15 and 30. And the positive divisors of 75 are 1, 3, 5, 15, 25 and 75. Therefore, the common positive divisors of 30 and 75 are 1, 3, 5 and 15 and the greatest of these is 15. Okay, here are 4 examples that illustrate a few different cases of division resulting in a quotient and a remainder. 100 divided by 45 is 2, remainder 10. Since the greatest multiple of 45, that is less than or equal to 100, is 2 into 45, 90, which is 10 less than 100. Example 2. 24 divided by 4 is 6, remainder is 0. Since the greatest multiple of 4, that is less than or equal to 24, is 24 itself, which is 0 less than 24. In general, the remainder is 0 if and only if c is divisible by d. Example 3. 6 divided by 24 is 0, remainder 6. Since the greatest multiple of 24, that is less than or equal to 6, is 0 times 24 or 0, which is 6 less than 6. Minus 32 divided by 3 is minus 11. Remainder 1. Since the greatest multiple of 3, that is less than or equal to minus 32, is minus 11 times 3 or minus 33, which is 1 less than minus 32. Here are 5 more examples. 100 divided by 3 is 33, remainder 1, since 100 is equal to 33 into 3 plus 1. 100 divided by 25 is 4, remainder 0, since 100 is equal to 4 into 25 plus 0. 80 divided by 100 is 0, remainder 80, since 80 is 0 plus 100 plus 80. Minus 13 divided by 5 is minus 3, remainder 2, since minus 13 is equal to minus 3 into 5 plus 2. Minus 73 divided by 10 is minus 8, remainder 7, since minus 73 is equal to minus 8 into 10 plus 7. If an integer is divisible by 2, it is called an even integer. Otherwise, it is called an odd integer. Note that when an odd integer is divided by 2, the remainder is always 1. The set of even integers is minus infinity to minus 6, minus 4, minus 2, 0, 2, 4, 6 till infinity. And the set of odd integers is minus 5, minus 3, minus 1, 1, 3, 5. Here are 6 useful facts regarding the sum and the product of even and odd integers. Fact number 1. The sum of two even integers is an even integer. Fact number 2. The sum of two odd integers is an even integer. Fact number 3. The sum of an even integer and an odd integer is an odd integer. Fact number 4. The product of two even numbers is an even integer. Fact 5. The product of two odd integers is an odd integer. Fact number 6. The product of an even integer and an odd integer is an even integer. A prime number is an integer greater than 1 that has only two positive divisors, 1 and itself. Again, a prime number is an integer greater than 1 that has only two positive divisors, 1 and itself. The first 10 prime numbers are 2, 3, 5, 7, 11, 13, 17, 19, 23 and 29. The integer 14 is not a prime number since it has four positive divisors, 1, 2, 7 and 14. The integer 1 is not a prime number and the integer 2 is the only prime number that is even. Every integer greater than 1 either is a prime number or can be uniquely expressed as a product of factors that are prime numbers or prime divisors. Such an expression is called the prime factorization. Like 12 can be expressed as 2 into 2 into 3, 14 can be expressed as 2 into 7 are the prime factors, 81 can be expressed as 3 into 3 into 3 into 3, 338, 2 into 13 into 13. An integer greater than 1 that is not a prime number is called a composite number. The first 10 composite numbers are 4, 6, 8, 9, 10, 12, 14, 15, 16 and 18.